Morning everyone. Today I'll be discussing about pixels. Where does pixels originated from? What is the importance of it and how does it used? So pixel is a combination of words from pix means picture and L for an element. So it all begins all the way back 1939 when the first practical commercially available process photography is introduced, and it was called daguerreotype. The daguerreotype is a direct positive process, creating a highly detailed image on a sheet of copper plated with a thin coat of silver without use of a negative. In 1816, the first permanent photography is taken by James Clerk Maxwell. What he did was capture three black and white images, each through a different filter, the red, blue, and green, by projecting each of these images back through their respective color filters and onto the screens. The final colored image was able to be reconstructed. This process of capturing just the primary colors of red, green, and blue light works so well that we still use it to this day because the red, green, and blue are our primary additive colors. You can mix them all together in different proportions to achieve any colors that you like. So in 1926, the first televised images using a mechanical television set that used a rapid rotating limb of scanning disc, and it was still a grayscale colored, limited to 12.5 frames a second and just a 30 lines of resolution only. So as you can observe, we're still talking about lines resolution. So pixels here hasn't been invented or discovered yet. So let's move on. So later on, in 1920s, the completely electronic cathode ray tube television set that we call the CRT was definitely superior to the mechanical television sets, especially it had no moving parts. In 1950s, colors television was first introduced. They work in very similar way and but the difference is it has three electrons that represents each primary colors. So earlier there is only one electrons that represent all of the three primary colors. So in 1950s here there are more than one electrons, and each of the electrons represent the three primary colors, the red, green, and blue. The beams would hit an array of colored phosphorus, which we call triads, and these triads are still not quite pixels, but colored TV that time was on 512 distinct horizontal lines. It wasn't until the digital age that those figure lines were further sliced into rectangles, which made representation of an image possible, and thus the pixel finally born. So in 1965, wherein the word pixel first appeared in print, therefore the pixel word has been published. See today, pixels come in variety of shapes and sizes on a variety screens like plasma, OLED, and LCD display, which have rendered the CRTs. As you can see, CRTs is the first model, and later on it slowly rendered because of its poor or slow. So let's go on. Pixel sampling pattern. Pixels are normally arranged in a regular two-dimensional grid. By using this arrangement, many common operations can be implemented by uniformly applying the same operation to each pixels independently. Other arrangements of pixels are possible, with some different sampling patterns, even changing the shapes of each pixels across the images. So for this reason, care must be taken when acquiring an image on one device, by displaying it on another, or when converting image data from one pixel to another format. For example, in LCD display. LCD screens typically use a staggered grid where the red, green, and blue components are sampled at slightly different locations. Sample also here. The vast majority of color digital cameras use a Bayer filter, resulting in a regular grid of pixels where the color of each pixel depends on its position on the grid. So as you can see in the sample, here the umbrella pixelized. The color of each pixel depends on its position on the grid. Another example is a clip map. A clip map uses a hierarchical sampling pattern where the size of the support of each pixel depend on its location within the hierarchy. So there are also grids are used when the underlying geometry is non-planar. This is commonly used as images of the Earth from spaces. Pixels in terms of color depth. Bits per pixel. The number of distinct colors that can be represented by a pixel depends on the number of bits per pixel, or BPP. A 1 BPP image uses 1 bit for each pixel, so each pixel can be either on or off. Each additional bit doubles the number of colors available, so a 2 BPP image can have 4 colors, and a 3 BPP image can have an 8 colors. So here is example, 2 channel, 8 colors total. So 1 BPP, 2 colors or monochrome, so 2 BPP, 4 colors, 3 BPP, 8 of 15 BPP or more bits per pixel. The depth is normally the sum of the bits allocated to each of red, green, and blue components. A high color, usually meaning 16 BPP, normally has 5 bits for red and blue each, and 6 bits for green, because as the human eye is more sensitive to errors in green than in the other two primary colors. So for applications involving transparency, the 16 bits may be divided into 5 bits each of red, green, and blue, with 1 bit left for transparency. A 24-bit depth allows 8 bits per component. On some systems, 32-bit depth is available, which means that each 24-bit pixel has an extra 8 bits to describe its opacity. So opacity is we use for purposes of combining with another image. So megapixel, familiar, right? So as you can see in the photos, this is the diagram of common sensor resolution of digital cameras, including megapixels values. So what is megapixels? A megapixel, or MP, is a million pixels. The term is used not only for the number of pixels in an image, but also to express the number of image sensors elements of digital cameras. or the number of display elements of digital display. So for example, a camera that makes a 2400 by 1536 pixels image typically uses a few extra rows and columns of sensor elements and is commonly said to have 3.2 megapixels or 3.4 megapixels, depending on whether the number reported is the effective or total pixel count. Pixel is used to define the resolution of a photo. Photo resolution is calculated by multiplying the width and height of a sensor in pixels. So, how does pixel affects the image quality and resolution? Resolution is determined by the ratio of pixels in proportion to image size. This is measured in ppi, pixels per inch, which is a high-resolution image will usually have more pixels to every square inch in an image. This is measured in which the number of diagonal pixels are taken as a proportion of the length of the diagonal line that goes through an image. The higher the PPI, the higher the image resolution, and this also means the higher the image quality. So image with lower resolutions have fewer pixels, and if those pixels are too large, usually when an image is stretched, they can become visible like the image below. It's become blurry. A dot pitch is a measure used to determine the sharpness on an image. So this pitch is what I have mentioned earlier, and this is measured in millimeters. And a smaller number means a sharper image. When you have closer spaced pixels, the image will look much sharper. The dot pitch is the distance from the center of one pixel to the next pixel. A lower dot pitch is considered better image quality based on its resolution. The latter would be much sharper than the former, thus having an image quality. So here is some possibilities. So when you change resolution of an image, you are saying how many pixels you want to live in each of the image. For example, an image that has a resolution of 600 ppi pixels per inch will contain 600 pixels within each of the image. 600 is a lot of pixels to live in just 1 inch, which is why 600 pixels per inch image will look very detailed and crisp or clear. Now compare that to an image with 72 ppi, which has a lot of fewer pixels per inch. As you have probably guessed, it won't look nearly as sharp as the 600 ppi. According to the resolution rule of thumb, when scanning or photographing, always try to capture the image at the largest resolution or quality as possible. Why? Because it's better to have more information than not enough. It's much easier for image editing applications like Photoshops to discard any unwanted images information, or what we call reducing the size of an image, and it is to create a new pixel information or enlarge an image. So this is the reason why professional photographers and seasoned imaging specialists prefer to work with higher resolution images because they have more pixels that store more information, and more information means more details, therefore much much better image quality than a lower resolution image. That's all for my presentation about pixels. Thank you for watching and God bless you.